In this video, we're going to learn about histograms. This will build upon knowledge from your GCSE. If you want a quick refresher, I'll put links to my videos on drawing and interpreting histograms in this video's description. There will also be a part of this video that uses direct proportion, so I'll put a link to that video as well. I am going to assume for this video though that you understand the content from all three of these ones. To begin with, we'll look at two exam-style questions that use the knowledge from GCSE, and then we'll start to explore how this topic is different at A-level. So for the first question, we have this frequency table here that's partially complete, and this histogram here that's also partially complete. When working with histograms, we use this formula, where FD is the frequency density, F is the frequency, and CW is the class width. Let's use this formula to complete both the table and the histogram. The first thing to notice in this question is the axis for frequency density is incomplete, so we're going to want to work out this scale. To do this, we need to find a bar on the histogram where we also have its frequency. Looking at this first bar here, that's between 0 and 20, we don't have the frequency for that bar. The second bar though, between 20 and 30, we do have the frequency, it's 6. So we can use this bar to work out the scale. We can see the frequency is 6, and the class width is the difference between the limits of this interval, so 20 and 30. So to find the frequency density, we do frequency, 6, divide by the class width, which is the difference between 30 and 20, which is 10. 6 divided by 10 is 0.6. This tells you that the frequency density for that bar is 0.6, and therefore its height is at 0.6. This will allow us to complete the scale, and each of those larger squares must be one whole, so it goes 1, 2, 3, 4, 5. Now that we have the frequency density scale, we're able to complete the frequencies in the table. Let's start with the first bar here, which goes from 0 to 20. To find the frequency, we're going to rearrange this formula, so it's frequency density multiplied by class width equals frequency. For this bar, the frequency density is 0.1, so we do 0.1, and we need to multiply this by the class width, which is the difference between 0 and 20, which is 20, so multiplied by 20. 0.1 multiplied by 20 is 2. This means the frequency for this bar was 2. Let's repeat this for the other missing frequency, which is the bar between 40 and 45. Here the frequency density is 4.6, so 4.6 multiplied by the class width, which is the difference between 40 and 45, which is 5, so multiplied by 5, and this gives you 23. So for this one, the frequency was 23. We've now completed the frequency table, but we need to fill in the missing bars on the histogram, and we have 2 more to add. To do this, we'll return to the original formula, frequency density equals frequency divided by class width. So we're going to do the bar between 30 and 40, which has a frequency of 13. So to get the frequency density, we do the frequency, 13, divide by the class width, which is the difference between 30 and 40, which is 10. So 13 divided by 10, which is 1.3. So this bar has a frequency density of 1.3, so its height must go up to 1.3. So we draw a bar in between 30 and 40 with a height of 1.3. Let's do this for the final bar, which is between 45 and 50. For this one, the frequency is 17, and the class width is the difference between 45 and 50, which is 5. So we do 17 divided by 5, which is 3.4. So the height of this bar needs to be 3.4. So we draw a bar between 45 and 50 with a height of 3.4. And that's your completed histogram. For the next question, we have this histogram here, and we're told the incomplete histogram shows the masses of 52 elephants. 6 elephants had a mass between 2,000 and 3,000 kilograms, and we're going to complete the histogram by adding a bar between 3,000 kilograms and 4,000 kilograms. It's possible to solve this question using area and not working out frequency density at all. We've been told that 6 of the elephants had a mass between 2,000 and 3,000 kilograms. That means that this bar here represents 6 elephants. If we work out the area of the bar in squares, it's 3 squares tall and 5 squares wide, which means its area is 3 times 5, 15. That tells us that 15 squares on this histogram represent 6 elephants. That must be the same across the whole of the histogram, so every 15 squares will represent 6 elephants. If we divide this by 15, it actually shows us that 1 square represents 0.4 elephants. So every single square on the histogram represents 0.4 elephants. We can use this fact to work out the number of elephants in the other 2 bars. This next bar here has a height of 15 squares and a width of 3 squares. And if you multiply 15 and 3 together, you get 45. So the area of the bar is 45 squares, but we know that each of those squares represent 0.4 elephants. So if we multiply 45 by 0.4, there must be 18 elephants in this bar. So this bar represents 18 elephants. And let's do the same with the final bar. This one has a height of 2.5 squares, a width of 12 squares, and if you multiply 12 and 2.5 together, you find this bar has an area of 30 squares. But each of those squares represents 0.4 elephants, so if we do 30 multiplied by 0.4, this bar represents 12 elephants. So there are 12 elephants in this bar here. So in the bars that we can see, we have 6, 18, and 12 elephants. That's a total of 36 elephants. We're told in the question there are 52 elephants though. So if we subtract 36 from 52, we find there are 16 elephants remaining. Those 16 elephants need to be in the bar that we've been asked to draw between 3,000 and 4,000 kilograms. Now that we know this bar represents 16 elephants, we can do 16 divided by 0.4, the number of elephants per square, to find that this bar must have an area of 40 squares. So we just need to draw a bar between 3,000 and 4,000 that uses 40 squares. The width of the bar is going to be 5 squares, so if we divide 40 by 5, we get 8 squares, which means it must be 8 squares tall. So we just draw a bar between 3,000 and 4,000 that has a height of 8. And there's your completed histogram. Next we're going to explore some of the differences between GCSE and A-level. If your exam board is AQA, then this is probably where you leave us, because the content assessed at A-level seems much the same as it is at GCSE. But if you're at Excel, there are plenty of differences that we need to look at. The next histogram shows the heights of some students at a school. Imagine you were asked to work out the number of students that had a height between 155 and 165 centimeters. We would normally work out the frequency density and the class width of that bar. The frequency density is the height of the bar, which is 3.5, and the class width is the difference between 155 and 165, which is 10. We would then use this formula here, and do the frequency density 3.5 multiplied by the class width 10 to get a frequency of 35. So we would say that this bar here represents 35 students. But what if I told you this was the frequency table, and actually there were 42 students that had a height between 155 and 165? This question highlights one of the key differences between GCSE and A-level. Previously, you would have learned that the area of the bar is equal to the frequency, but actually the area of each bar is proportional to the frequency. That means we need to adjust this formula, and rather than being equal to, it needs to be proportional to. Another way that we could write this is that frequency density multiplied by the class width, which is the area of the bar, is equal to k, some constant, multiplied by the frequency. In this question, we're now going to work out the value of k to allow us to complete the table and the histogram. We'll start by substituting in the values we found. The frequency density was 3.5 and the class width was 10. But this must equal k multiplied by the frequency, but we know the frequency of this bar is 42, so it equals k times 42. We then multiply 3.5 and 10, which is 35, and k and 42, which is 42k. If you divide both sides by 42, you find that k is equal to 35 over 42, which will simplify to 5 over 6. If we now substitute k back into the original formula, we find that frequency density multiplied by class width is equal to 5/6 multiplied by the frequency, or 5/6 of f. This means that for this histogram, the area of the bar is actually equal to 5/6 of the frequency and not the frequency itself. We can now use this to find some more frequencies. Let's look at this bar here, which has a height or frequency density of 2 and a class width of 15. If we substitute these into the formula, 2 times 15 must equal 5/6 of the frequency. 2 times 15 is 30, so we have 30 equals 5/6 of f, and if you multiply both sides of this equation by 6 and then divide both sides by 5, you'll find that f must be equal to 36. So the frequency of this bar is not 30, but 36. Let's try this for the next bar. This one here has a frequency density of 7 and a class width of 5. So if we substitute those in, we have 7 multiplied by 5 is equal to 5/6 of the frequency. 7 5s are 35, and if you solve this equation, you'll find that f is equal to 42. So for this bar, the frequency is 42. Why don't you pause the video and see if you can work out the final frequency yourself. So for the final bar, we do the frequency density, which is just 1. The class width is 15, so we do 1 multiplied by 15 equals 5/6 of f. 115 is just 15, and if you solve this equation, you'll find that f is equal to 18. So the remaining frequency was 18. This histogram also has a missing bar between 165 and 170, but we do have the frequency for that bar, it's 57. So this time we can substitute 57 in for the frequency. If you do 5/6 of 57 on your calculator, you'll get 47.5. The class width for this bar must be the difference between 165 and 170, which is 5. So we can substitute the class width for 5. So we have frequency density multiplied by 5 equals 47.5, which we can solve by dividing both sides by 5. This will give you frequency density equals 9.5. So the frequency density for this bar is 9.5, which means we need to draw it with a height of 9.5. And that's your completed histogram. So it's really important to remember that the area of the bar is not necessarily going to be equal to the frequency, but proportional to the frequency. In many of the questions it will still be equal to, in which case the value of k is just 1, but it is something for you to watch out for. Let's have a look at another question. In this question we have a histogram, and this one is about the annual income in thousands of pounds of workers at a company. The question says, the histogram shows the annual salaries of 40 employees at a company. Use linear interpolation to estimate the interquartile range. So in this question we need to combine histograms with linear interpolation, a topic I covered a few videos ago. The first thing we want to do here is work out the frequencies and just double check that the area of each bar is equal to the frequency. So if we were to draw out a frequency table for this one, if we multiply the class width of 10 for the first bar by its frequency density of 0.4, we'd end up with 4. If we do the same for all of the other bars, we end up with 7, 9, 11, and 9. If you add together all of these frequencies, you get 40, which is what we were told in the question. So for this question, the area of the bars is indeed equal to the frequencies, just like it was at GCSE. Now we're going to try and work out the lower and upper quartiles. Since this data is grouped and continuous, we would use n over 4 and 3n over 4 to work out the location of the lower and upper quartiles. N is 40, so we do 40 over 4, which is 10. This tells us the lower quartile is in the 10th position. If we do 3 lots of 40 over 4, we get 30. This tells us the upper quartile is in the 30th position. To work out which groups these fall in, we're going to work out the cumulative frequency. So we'll bring back this table and add a column for cumulative frequency. The first one is 4, then if we add on 7 we get 11, adding on 9 gets us 20, adding on 11 is 31, and adding on 9 is 40. This tells us that the 10th position must be in this group, and the 30th position must be in this group. We don't actually need the histogram anymore to solve this question. Let's draw out a diagram to help us locate those quartiles using linear interpolation. So we'll do the lower quartile first. This is in the group between 20 and 25, where the cumulative frequencies go from 4 to 11. We're looking for the 10th value, which will be somewhere near the right hand side. The difference between 11 and 4 is 11 subtract 4, which is 7. The difference between 10 and 4 is 10 subtract 4, which is 6. The difference between 20 and 25 is 5. And then we have this difference here, which is what we want to find out, so we'll call that x. We then form the equation 6 over 7 is equal to x over 5. If you multiply both sides of this equation by 5, you find that x is 4.285 and so on. This will mean the value of the lower quartile is 20 plus x, so 20 plus 4.285, which will give you 24.285 and so on. So the lower quartile is 24.285 and so on. I'm not going to demonstrate the full process again for the upper quartile as I already have a video on how to use linear interpolation. You're welcome to pause the video and give it a try now, but if you do it correctly, you'll find that Q3 is equal to 31.63 recurring. To find the interquartile range then, we subtract these two values. So if you do 31.63 recurring, subtract 24.285 and so on, you end up with 7.3510649,351. Remember these values are in thousands of pounds though, so we need to multiply this by 1000. This number multiplied by 1000 gives you £7,351 and 6 pence if we round it to the nearest pence. So this question has shown that histograms can be combined with other A-level content. Let's bring back the histogram and look at another difference at A-level. If you did Edexcel at GCSE, you may have learned how to draw a frequency polygon, and we can draw a frequency polygon onto this histogram. To do so, we draw a cross at the center point of the top of each of the bars. So here, 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 and here. We then connect these crosses together with straight lines. So this forms a frequency polygon, and this may be drawn onto a histogram already for you in the exam. Another topic that you've learned at A-level is the mean and standard deviation. You could be given a histogram just like this one here and asked to work out estimates for the mean and standard deviation. To do that, we would use the calculator. We would take the calculator and enter a frequency table. When we do so, we want to make sure that these x values here are the midpoints of the groups. So you can see the first one is between 10 and 20, I've entered the midpoint of 15. For the frequencies, you just enter the frequencies, but make sure you do not enter the frequency densities here. You can then just get the calculator to work out the statistics for you. You'll find that the mean for this one is 28.875 and the standard deviation is 7.814 and so on. Remember, these are in thousands of pounds, so the mean would be 28,875 and the standard deviation 7,814. It really is just as simple as typing this into the calculator, but you must take care to make sure you use the midpoints of each of the intervals and enter the frequency and not the frequency densities. Something else that we've looked at in previous videos is when you're given a frequency table that looks like this. Let's imagine we had this frequency table and we were asked to draw a histogram. You may be told in the question that these temperatures were rounded to the nearest degree. So for the first group with temperatures between 20 and 24, the lowest possible value is actually 19.5, since that will still round up to 20. And the upper bound is 24.5. This means we're going to need to rewrite these intervals here. So if we take another table with the same frequencies, we could rewrite the first group as temperatures, let's call them T, in between 19.5 and 24.5. The next group is in between 24.5 and 29.5, and then between 29.5 and 35.5, and 35.5 and 43.5. We work out the frequency densities by doing the frequency divided by the class width. So for the first group, 6 divided by the class width, which is the difference between 19.5 and 24.5, which is 5. So 6 divided by 5, which is 1.2. For the next group, we divide 7 by the difference between 24.5 and 29.5, which is 5 again. So 7 divided by 5, which is 1.4. The next group is 3 divided by the difference between 29.5 and 35.5, which is actually 6 this time. So 3 divided by 6 is 0.5. For the final group, it's 6 divided by the difference between 35.5 and 43.5, which is 8. So 6 divided by 8, which is 0.75. We can now draw the histogram. The first bar goes between 19.5 and 24.5 with a frequency density of 1.2, so it looks something like this. It might feel a little bit strange, but this bar is in the right place. We then repeat this for the other bars, so between 24.5 and 29.5 up to 1.4, that would go here. Between 29.5 and 35.5 up to 0.5, that goes here. Between 35.5 and 43.5 up to 0.75 goes here. So you need to be careful if data is given to you in this way and the question specifies that the values were rounded to the nearest, say, degree, or whatever the context of the question is. We're now going to look at one more final example of a type of question you can be given on histograms. Take this histogram here, and the question says, the histogram shows the time spent on a website in minutes by 1,620 users. The website owner models the frequency density of the 1,620 users by a curve with equation y equals k minus x squared, where x is in between 0 and 12 and k is a constant. The question wants us to find the value of k. This question is going to require the use of integration, so if you haven't covered integration yet, you won't be able to do this question. You might want to save the video and come back to it when you have covered integration later in the year. First of all, if we do a quick check and work out the area of each of these bars, we get these numbers here. This does add up to 1,620, so for this question, the area of each of the bars is equal to the frequency. So what's this question asking us to do? Well, the area of all of these bars makes a total of 1,620. This question is saying we're going to use a curve to model the frequency density instead, which means the area under this curve is going to need to be equal to 1,620, specifically if we go between x values of 0 and 12. To find the area under a curve, we use integration. So if we do the integral between 0 and 12 of this curve, this will need to be equal to 1,620. So let's integrate this and see what happens. So let's write down our brackets and our limits of 0 and 12, and let's integrate. The integral of k will be kx, then we have subtract, and for x squared we would add 1 to the power, so x cubed, and divide by this new power, so divide by 3. If we now evaluate this, we would substitute in 12. So we'd have 12k subtract 12 cubed over 3. Then we would subtract and then substitute in 0. So 0k, which is just 0, subtract 0 cubed over 3. Now 0 subtract 0 cubed over 3 is just 0, so we're subtracting 0, which means we're subtracting nothing, so we can lose this part here. Which means that this must represent the area underneath the curve between 0 and 12. But we know that this area needs to be equal to the total frequency, which was 1620. We now just need to solve this equation to find k. If we multiply both sides by 3, we get 36k subtract 12 cubed equals 4860. Adding 12 cubed to both sides gives us 36k equals 4860 plus 12 cubed, and if you divide both sides by 36, you find that k is equal to this over 36. If you type that into your calculator, you'll get 183, which is the answer to the question. What this means is if we substituted k equals 183 into this equation of the curve's equation was 183 subtract x squared. If we draw the graph of y equals 183 subtract x squared onto the histogram, it will look something like this. That means the area underneath this curve here is also 1620. And you can see this is actually quite close to where the bars are on the histogram, so this does make a lot of sense. Thank you for watching this video, I hope you found it useful. Check out the one I think you should watch next, subscribe so you don't miss out on future videos, and why not go and try the exam questions I've written that are in this video's description.